So in this video, we're going to be looking at solving the sixth trig function given a constraint. So let's take a look at what our constraints are. In this case, they tell us what sine is. It's 3/5. And they tell us that theta, which is basically the angle, is in quadrant 2. So first off, in my mind, I'm thinking, okay, I need to draw a picture of this angle being in quadrant 2. And so quadrant 2 is right here where x's and y's, x's is negative and y's are positive. So I'm starting to see kind of like, okay, I need to see that x here are negative and y's are positive. And so what do I know about sine? Well, sine is always y over the radius. In this case, I know that the y value is 3 based off my fraction and my radius is 5. So I already know that in this case, y is equal to 3 and the radius is 5. That's a lot of information to work with. And so if I were to kind of draw this triangle out in the second quadrant, I know that this side here is 3 and the radius here is 5. So I don't know what x is, but lucky for me, I can figure that out using the Pythagorean Theorem, which is x squared y squared equals r squared. So if I don't know what x is, I can leave that as a variable, but my y here is a 3, and my radius here is a 5. And I can work this out. And so we would get x squared 9 equals 25. If I square the numbers, move the 9 over, so I have to subtract it from 25, which gives me 16. Take a square root of that, and that's 4. So if I take a square root, this would give me 4. And so, oops, I think I accidentally wrote this as x squared. I didn't mean to. That is going to be an x. And so x is equal to 4, and I filled in that piece for myself. And so given this, I need to ask myself, okay, this is a positive 4 that I got out, but is it a positive 4 on the coordinate system? This is when I really want you guys to think about, is the x and y's correct here? Is it supposed to be that correct sign? So 3 here we got as a positive number, and y should be positive here because it's in the second quadrant. The y values are positive, but this x value here is not positive. It should be a negative value. So that's where you want to add in your negative value for x. So I'm going to make this as a negative 4. All right, so then from there, I have all 3 pieces of the triangle. If I have all the sides, I'm ready to find my 6 trig functions. Now I want to mention, as a reminder, your radius should always be positive, and it is here. That's the only thing that is always going to stay positive, is that radius. All right, so to find these trig values here, we have sine, cosine, tangent. And so sine here is y over r, x over r for cosine, and tangent is y over x. And so if I were to find sine, this would be my y value, which is 3, and my radius, which is 5. So 3/5. My x here is negative 4, and my radius, again, is 5. And my tangent is 3/4. And there we go. Now, I want to mention that these numbers were reduced, so there was not much that I needed to do here, which is kind of nice. After that, you will need to find your reciprocal. So with that part, you just flip the first 3. So I'm going to write in cosecant, secant, and cotangent. So for cosecant, it's just your reciprocal, so r over y, and secant is r over x. By the way, you don't need to show what is the identity or writing identity, which means that you don't have to write r over y or r over x. I like to do this as a beginner because it really helps establish that connection of using the formulas or the identities. So I think it's a good habit. But you can go ahead and just flip these. So this one would be 3 or 5/3, 5 over negative 4, and negative 4 over 3. And there we go. We have all our 6 trig functions. Okay, let's go ahead and find our next one with our constraint here. So they get a little bit trickier every time, but I want to kind of build up to the difficulty. So this one here is secant, and you have a negative 2, secant's equal to negative 2. And they also tell you that sine's angle, if you took the angle and you took the sine of it, it would be greater than 0. That's a lot of information going on here. But I want to first focus on this part because it's something that we should be familiar with. Anytime it's saying that, that angle is bigger or greater than 0, that's saying that this thing is positive. So I just want to put a little reminder. It's saying that sine here is positive. And when we think about when sine is positive, you might remember, all students take cash. And that's saying that in this case, all of the angles are positive here. Only sine is positive in the second quadrant, and then the rest are positive for tangent and cosine. But what we care about is when is sine positive? Well, it's positive in the first quadrant and in the second quadrant. So that's what I'm going to make a note of. So quadrant 1 and quadrant 2. For this one, we also really want to figure out what quadrants does this statement is true. To understand that, we need to understand secant. So secant is, let's write out secant for a moment, is going to be our r over x. It's the reciprocal of cosine. If that's the case, this is equal to negative 2, or we can think of it as negative 2 over 1, right? Here's the thing. We know that the radius can never be negative. So this 2 can't be a negative 2. So I'm going to go ahead and erase that part right there and write this as a positive 2. That means that the x had to have been a negative 1. So let me just rephrase that. I figured out what secant is by using the identity. So secant is r over x. This is negative 2, but negative 2 can be written as negative 2 over 1. Which is how I wrote it. But then I remembered that the radius is always positive, so that negative sign had to go down in the denominator to make this a negative 2. So the radius is 2, and the x is the thing that's negative. If that's the case, when x is a negative, it only can be in the second quadrant and in the third quadrant. So when I compare these two conditions, the only place that they can both be is the second quadrant, because that's where they both pulled up. So the second quadrant here is the winner. So I know where to place this picture now. So that is how we kind of wrap our minds around this problem, is figure out what is our constraint and where does it constrain in which quadrant. And so figuring out which quadrant you're in can be the tricky part. So this is negative and positive for y since we're in the second quadrant. And I already know that this radius here, that's a terrible angle, let me redraw that, is 2, because secant here is a negative 2, so that radius is a 2. And then my x value is a negative 1, which makes sense because I'm in the second quadrant. And so my x here looks like it's pivoting out, 1 unit to the left. And then I need to figure out what y is, which they didn't tell me, but I can find it. So using the Pythagorean Theorem again, I plug in my x, which is negative 1. Just square it. I don't know what y is. And my r here is 2, so 2 squared. So that gives me 1r2, and this would be 4. Y squared, subtract over the 1 is 3. Yep. And so if I take a square root, this would be root 3. So that tells me that my y value here is, let me go ahead and write that a little bit bigger, is root 3. All right, now that I have all 3 sides of the triangle, I am ready to figure out all the 6 trig values. So I have sine, cosine, tangent. And so sine is the y over r, cosine's x over r, and tangent's y over x. And so my y here is root 3, and my radius is 2. And then my x value here is negative 1, and my radius is 2. My y value is root 3, and my x is negative 1. Now, for these first two, I didn't have to reduce them because they're already reduced as they are. But this one here is root 3 over negative 1. If I divide by a 1, that's just itself, so root 3. But I do need a negative since this did have a negative sign on the denominator. So that is my first 3 trig functions. So I'm ready to find my reciprocals. So I have cosecant, which is r over y, secant, which is r over x, and cotangent, which is x over y. So if I were to flip this here, this would be 2 over root 3, which I have to rationalize the denominator since I can't have a root in the bottom. And then I would have 2 root 3 on the top and then a 3 on the bottom if I multiply this out. And then I can't reduce it, so I'll keep my answer like this. For the next one, I'll also have, looks like I have a 2 on the top now is my radius and a negative 1 on bottom. So if I were to clean this up or divide 2 by negative 1 is going to be negative 2. And then for cotangent, I have x over y. So my x here is negative 1. Oops. Negative 1. And then my y here is root 3. So again, I can't have a root in the bottom. So I'm going to multiply the top and bottom by root 3. And this ends up being negative root 3 and 3 on the bottom. And there we go. We have our 6 trig functions. Okay, let's do one more here for C. So C is a tangent value, but we're going to do the same thing. I want us to first look at the constraints, starting with tangent here. So tangent is also being compared to a whole number. So remember now, we can always write a whole number over 1 to make it look like a fraction. And what I need to understand is that this tangent here is a negative, right? And if tangent is a negative, if you go back to the chart, all students take cash. This quadrant 1 and 3 are the only places that tangent can be positive. That means tangent can be negative in quadrant 2 and quadrant 4. So let me write that down. So quadrant 2 and quadrant 4 is where tangent can be negative, is what I'm reminding myself. Now, from here, I'm going to write down which one I could possibly think, which quadrant tangent can be in, but I'm not sure yet. So what I'm going to do is maybe help myself out by looking at what this quadrant could be in. So cosine is less than 0. If that's the case, this is saying that this cosine is negative, because something that's less than 0 would have to be negative. And so when cosine is negative, let's ask yourself, when is cosine positive? So cosine is positive in the first quadrant and in the fourth quadrant. So that means cosine can be negative in the second quadrant and the third quadrant. So second quadrant and the third quadrant. Well, if that's the case, that means that the second quadrant is where they're going to be located. If it's in the second quadrant, if we kind of draw a second quadrant here, second quadrant, the x value is negative and the y value is positive. So for this situation, if we know what tangent is the y over x. So that means the y is always positive here. And so this 4 is actually a positive for y. and it's the x value that's negative in the second quadrant. So this 1 here is actually a negative 1. And so I already know what x's and y's are. If I were to draw this picture here, I know that my x here is negative 1 and my y here is 4. And that should make sense because I'm in the second quadrant. Now from there, I can figure out my radius. And so to figure out the radius, use the Pythagorean. So I have x, which is 4. Oh, sorry, not x. My x here is negative 1. And I have my y, which is 4. So if I work this out, this would be 1 plus 16, which ends up being 17. And 17 is not a nice square root because 17 is a prime number. So we'll just have the root of 17. So it looks like my radius is root 17. All right, from there we have all 3 sides of our triangle, so we're ready to find our trig ratios. So we have sine, cosine, tangent. Sine is y over r, cosine is x over r, tangent's y over x. So our sine here is going to be 4 over root 17, which won't do because, you know, the root is in the denominator, so I need to switch that on the top and bottom. And so I've cleaned it up after I've multiplied it straight across. 4 and 17, they don't reduce, so I'll leave my answer like this. For cosine, I would have x first, so negative 1, and then root 17 on bottom. And again, I have to rationalize since I have that root 17 on the bottom. So this gives me negative root 17 on top, and then a 17 on bottom. For tangent, I have y over x, so that's going to be 4 over negative 1, which ends up being negative 4. Kind of a nice answer to see. All right, and then for the reciprocals, we have cosecant, which is going to be r over y, and we have secant, r over x, and then cotangent, which is the x over y. And so if we go back to cosecant here, cosecant is going to be the reciprocal of sine, so I'm just going to flip this guy. Which is root 17 over 4. And this here, I can't reduce, so I'll just leave it the way it is. And the root's on the top, so I'm not worried. So I'll just leave my answer like that. And then for secant, that is this piece here. The radius is root 17 and the x is 1. So I'm going to write the root 17 on top this time and negative 1 on bottom because it's a reciprocal. And if I were to clean it up, all I can do is divide by 1, which ends up being negative root 17 as my answer. And then finally, cotangent here is x over y. So if I were to flip this here, I would have 1 over, negative 1 over 4, which I could just leave my answer like that. There would not be much of anything I could do to reduce that. So I'll just leave my answer like that. And then that there is all my 6 trig functions. And there we go. All right, that's it for this video. In the next video, I'll talk about finding specific trig values given a specified quadrant.